Let's do another example using the chain rule, this time with a root function. So here we have y equals the square root of 3 to the x minus sine x. So here, the fundamental operation occurring is composition. Because if we were going to compute what y was at a particular x value, we would have to compute 3 to the x minus sine of x and get that answer. Then our very last step would be to take that answer and input it into the square root function. That would be our last step. So, since we have a composition, we know that we would take 3 to the x minus sine of x. We would get that answer, and then we would input it into the square root function. So that's our inner function, 3 to the x minus sine of x, and we call that u. To find our outer function, we're going to take our definition of y, and now everywhere where 3 to the x minus sine x appears, everywhere where this appears, I'm instead going to write u. So our outer function is y equals square root of u. To compute the derivative, we need to find du dx and dy du. So to get du dx, we take the definition of our inner function and we get 3 to the x times natural log of 3 minus cosine of x. And now we find the outer function. We compute dy du, and dy du is 1/2 u to the negative 1/2. So the chain rule set tells us that dy dx equals dy du times du dx. Again, I'm going to do this in 2 steps. So at first I get 1/2 u to the negative 1/2 du dx. And then in my next step, I'm going to replace u with our definition of u, 3 to the x minus sine of x. Okay? And at the same time, I'm going to replace du dx with our du dx. So I get 1/2 3 to the x minus sine of x to the negative 1/2 times 3 to the x, natural log of 3, minus cosine of x. And there is our derivative. So let's really go through the steps one by one of what's happening here. It looks like the first thing we do is we find the inner function and we set it equal to u. Okay, so our steps. Number 1, we need to determine the inner function. And then we need to set it equal to u. Okay, so then let's go back and see what do we do next. After we determine the inner function and set it equal to u, we determine the outer function. And the way that we do that is we replace the inner function in the function we're differentiating in the composite with u. Okay, so the second thing we do is we substitute u for the inner function in the composite definition. And this tells us the outer function. Okay, after we do this, we differentiate the inner function to get du dx, and the outer function to get dy du. Okay, that's what we did over here on the right. That's what we do over here on the right. Du dx is the derivative of the inner function with respect to x, and dy du is the derivative of the outer function with respect to u. Okay. After we have both of those, we substitute them into the chain rule. Okay, so let's write that down. We substitute in 2 steps into the chain rule. So in chain rule, which is dy dx equals dy du times du dx, we substitute in dy du, and this answer usually has a u in it. Or at least one u. And then step 2 in substituting in is that we substitute in for u and du dx at the same time. So we substitute the inner function for u and for du dx. So our final answer should only have x's. So the final answer should only have x's appearing. And we're going to keep doing these steps over and over and over again until they become second nature.